And aggregation. Aggregation is a special case of the associations. It's a special case of the association. Let's imagine this. We have one customer, right? Customer has many products or purchases. Let's say purchases. Okay, this can happen, and this will be purchase. And if customer has 0 purchase, does it mean that customer should go away? Actually not. Even though customer has 0 purchases, we might want to store the customer's history or customer's name or something. So still this customer, the meanings of this customer doesn't die. But let's imagine this case. We have one-to-many family members, right? And this family exists by through the family consists of these family members, right? And without the family members, family cannot survive, cannot exist. So if family member becomes zero, means that this family should go away. So really, this holder of the family member, this family class, holder of the family members, really depends on the numbers of the family member. And if the number of the family members becomes 0, then this family class is not going to be meaningful any further, and it's going to be destroyed, right? And in this particular situations, the above case, even though we have 0 purchases, customers may still there. But family members, if there are no family members, the family cannot exist. So if this kind of life cycle depends on it, means that it's a special case of the association, and we call it aggregation. Okay, and this diamond point attaches to a class depending on the existence or more like multiplicity of the other size, right? And here we have, actually there is a simple arrow here, and it's one-to-many. Of course it should be one-to-many, because if there is one family class, there should be at least one family member, right? So this aggregation relationship is a special case of the association. The class life cycle depends on the collected classes, right? Finally, the dependency. So dependency is kind of the most simple one. Dependency between classes is a kind of use relationship. For instance, an engineer uses a calculator many times. So what happens here is that there is a class definition engineer. So it's here. And in the methods, to calculate something, we instantiated calculator. And this calc can only survive throughout this function block. And after hitting end, calc will be destroyed. Okay? It's not a properties. If it was properties, then it will survive after function block ends. But it's going to go away, right? So in that case, this engineer class simply use this calculator class for a simple usage, function usage. In that case, we use this dotted line and the simple arrow to show that dependency between the engineer and calculator. And because engineer depends on this calculator, the arrow starts from the engineer and ends at the calculator. Okay? So let's practice. Now we cover the association case, and this is what? This is the aggregation. And we covered the multiplicity, and we covered navigability, and we all knew this, right? And we have role names, and we run that in the association class, association relationship case, and we already know the abstract class, and we run the generalization relationship, right? So let's practice. This customer, there should one customer has a name and address, and it may have 0 orders or many orders, right? And each order should have 1 or more payments, and these payments should be must be either credit, cash, or check, right? Because it's abstract class, we should have generalization, and we are only going to instantiate the full class, complete class, overriding the abstract methods. And then these orders cannot exist without the order details. And order details should be there should be at least one or many, and each order detail might have 1 item here, right? Okay. So, and each item can be included 0 order details or many order details. Okay. So here we have this multiplicity. Okay. So these are the simple diagrams and how to read these diagrams. And coding these diagrams, we already showed these parts of these relationships, and we gave examples. And what you are going to do is that not just this class diagram, you are going to use the sentiment analysis case, but we are going to make more elaborate class diagram for the sentiment analyzer, and we will make that program more organized and design it by using UML. Okay. So that's the end of this part 2 of the week 2. And what we are going to have is the week 3, the part 3. And in the part 3, I'm going to cover some design patterns. And in my previous years, I covered these design patterns very briefly. Like we already spent quite a amount of time to cover to teach you how to program and how to organize programs and how to design programs so far, right? So so previous years I tend not to cover this very briefly. But this time, what I'm going to do is that I'm going to record the video clip for this, and it's very kind of useful things if you are really serious about the software design. So I recommend you to listen. But this is really supplementary purpose. Okay. So that's it. I'm going to see you in the next part 3 of the week 2. Okay, thank you.